In the previous video, you saw the theory on primitive data type variables into Java. Now, in this video, we are going to cover all these primitive data types practically. Now, I've already exported the code to this GitHub repository. And now, since you are watching part 5 of this video series, you have to select part 5 branch. When you do so, you would see this folder. Just click on this. Now, these are the different files, but you have to concentrate on this source folder. You click on that, and this is the main file where I'm going to write all the code. Okay, all right, so let's start writing the code. Now the first step is we have to create a variable. So guys, creating a variable is a two-step process. Step 1 is declaration and step 2 is initialization. So in declaration, you provide the data type first and then a space, then name of the variable, like so. Okay, so you say int age, meaning you have created a variable of name age and it is of type integer. Now initialization is when you set its value to something. Okay, so we say age is equal to 20. So this is declaration and this is initialization. Now you might be wondering, why do you need to break this process down into two steps? So at times, you do not know the value of these variables ahead of time, but you know that whatever the value is, it would be of type integer, let's say. Okay, so in those cases, you declare the variable first and initialize this at later point of time. All right, now to log this to the console, we just have to say, this is a shortcut, syso, then you press control space and then you get the system.out.println and then you mention the name of the variable. Save it. To run this, just say right click and run as Java application. Okay, so we see the output as 20. Great. So guys, types of variable is our next thing. There are four type of variables: local, instance, class, and arguments. Now this int age is the local variable. What is a local variable? A variable declared inside the body of the method is called as local variable. Now public static void main, okay, this is a method, all right, and this is the opening curly braces, and then you have this closing curly brace. Okay, now this variable age is accessible only within this method, and any other method in this class have no idea about the existence of this variable. The other thing that you have to understand is, with this local variable, you can't use public, okay, you can't use static. So I mentioned that there are two type of modifiers: access modifiers and non-access modifiers. Okay, so the only thing that you can use in here is final. Okay, if you use anything else, okay, like let's say public, and if you hover over this, it says illegal modifier for parameter age, only final is permitted, right? So from the list of access and non-access modifiers, the only modifier that is allowed or permitted is final, like I mentioned. Okay, great. So this is my local variable, then local variable, right? Then you have the instance variable. Now what is an instance variable? A variable declared inside the class but outside the body of the method is called as instance variable. It is called as instance variable because its value is instance specific and is not shared amongst instances. It is also called as instance property or instance field. So guys, like I explained, if you have to create the instance variable, you have to create it outside the method body. So we come in here and we say int instance variable, okay, like so. Now you can use the access modifiers like public, private, and so on. Okay, then the next one is class variable, or this is also called as static variable. A variable which is declared as static is called as static variable. You can create a single copy of static variable and share among all the instances of the class. Memory allocation for static variable happens only once when the class is loaded in the memory. It is also called as class field or class property. So again, you have to create it outside the method body, right? So you say first we have to provide in the access modifier, so we say public, then you have to provide in the non-access modifier, and for class variable it has to be static. Then you have to provide in the data type. All right, so we say int again, and then we say the name of the variable. So we say class variable, like so. So this becomes your class variable. This is your instance variable. This is your local variable. Now we have one more type, which is argument. So in this method, all right, you're passing in this argument. So this become your argument. Okay, that's another type of variable. All right, so we have covered all these. Then we have, why do we call it as variable? Okay, because its value can change. Okay, so we can say, for example, in here we have said age is equal to 20. You can change it to age is equal to 30 now. Okay, like so. So that is allowed. What is not allowed is you set it to some other data type like so. Okay, this is not allowed. And if we hover over this, what do we see? Type mismatch, cannot convert from string to int. Okay, so this is how we write string. We have not covered string. I'm gonna create a separate video on string. So let me comment this out. Okay, default values. Okay guys, now let's understand this. Initialization is important for local variables, but in case of class and instance variables, they always get the default value if not initialized. So let's start with creating a local variable. We say int num, like so. Okay, now we are going to log out all these types to the console. So I, in here I say num. Okay, then I do the same with class and instance variable. So I say class var. Okay, and same way instance var, like so. Now guys, in here we are getting the error. Why? Because we have not created an instance of this class. To access the instance variables, you have to first create the instance of the class, and hence it is complaining. But in case of class, you are not seeing any complaint from the compiler. But how to use the class variable? So you use with the help of class name. You say class name dot, and then you see this class variable, right, like so. For instance, you have to create the object of this. How do we create the object of this? So we create using the new operator. So we say new, then the name of the class, and these parentheses. Now you have the object, guys. And when you do a dot now, then you would see that instance variable. I'm going to cover all of this in an upcoming video, so don't worry about that. So you have created an object of this class, and then you have access its property using the dot. Okay, this is how you can access it. But in here guys, you see we are getting an error. The local variable num may not have been initialized, but in here we are not getting any such complaint. So you can't run this, but you can run these two. And when you do so, okay, remember I mentioned that they are default values. So for int, the default value is 0. Okay, so we'll see 0 in this case and 0 in here as well. So if I save it and run this, right, so you see 0 and 0. Great. Now guys, we have created so many variables. Okay, but do we have to follow certain naming conventions? Yes. So let me show you all the rules. So name can contain letters, digits, underscore, and dollars. Nothing else is allowed. Okay, no special character besides underscore and dollar are allowed. Let's check that. So if I say int age and I add, let's say hash. Okay, so you see we get an error. Now if you add a dollar, all right, so there is no issue in here. Underscore, so this is also allowed. Okay, now let's look at the other rules. Name must begin with either letter or dollar or underscore. Okay, meaning that I can't start the name of a variable with a number. So if I say 3 age, we again get an error. All right, what else do we have? So name should start with a lowercase letter and it cannot contain white spaces. Okay, so we start the name of the class with the capital letter. alright. But in case of variable, we always start the name of the variable with a small letter. And in here you see there are two words, okay. There is no white space in between, okay. There should not be any white space. Then we use the camel casing format. So we start with a small case, but make the first character of the next word capital, like so, in case of instance variable as well as class variable. You see that. Okay. Now guys, this is very important. Java is a case sensitive language. So class var and this class var, okay, are different variables. Why? Because in here we have the capital V and in here we have the small v. So if you try to access this, okay, it will not work. You get an error. Okay, class var cannot be resolved or is not a field. All right, so Java is a case sensitive language. Always remember that. Then we cannot use the reserved keywords like int or boolean, okay, for naming our variables. So again, that is not allowed. So alright guys, we have got 8 primitive data types. Okay, when to use which one depends upon the range. Let's start with byte. So I say byte num1 and I can store, let's say, 70 into it, like so. Okay, same way I can also store characters into this. So I say byte and I say numchar is equal to, in single quotes, I can store a as well. Now why this byte can store both numbers and character? Because it works with the sky value. So in your browser, just search for sky table and you will see this. Okay, so we have used 70. Now 70 represents F. Okay, and in here you see A. So A has a numeric value of 65. Now when you save this, which one would be picked depend upon how things are interpreted. Right? Then we have got short. Okay, so I say short and I use num2 is equal to, now this 2 has a range, minus 32,768 to 32,767. So any value that you would like to store which falls within this range, go for short, because short takes in what, 2 bytes. Okay, so you can store 32767. Okay, that is the maximum value that you can store into it. If you store anything beyond this range, you get an error. You say type mismatch, cannot convert from int to short, right? Because this is the integer value, so this can't be stored into short. Okay, so this is the maximum value that you can store into this. Now if you want to store a larger value, guys, okay, you have to use int. So you say num3 is equal to, now let me write in the maximum value that we can enter in here. This is the maximum value that you can store into integer. Now if you add this, right, you get an error. The literal of type int is out of the range. Now what is this literal? Okay, so literal is nothing, it's any constant value which can be assigned to a variable is called as literal. Now guys, one more thing, so you can't use comma or dots like so. Okay, again you will get an error. So let me first correct it to the maximum value. So see, this is not allowed in programming. Okay, but if you are using JRE version 1.7 and above, you can use underscore like so to enhance the readability. That is allowed. Then guys, if you want to store the value larger than this, you have to go for long and you have to say num4. Okay, and let me use the same value now. All right, so this is allowed, but let me show you one thing. If you store a value which is greater than the maximum value of integer, for example like this, still you are getting that error. So it says literal of type int is out of range. That means that int is the by default data type for numbers. So if you want to store longer values, you have to either use a small l or the capital L to tell to the compiler that hey, this is a long data type variable, and then it is allowed, no issues. Okay, now this is when you have to work with whole numbers. Now if you have to work with the decimal numbers, you have to go for float and double. So again we say float and then we say num5 is equal to, and you can store the values 23.567 perfectly fine. Okay, but you see we get an error. Why? Well, by default, data type for storing decimal into Java is double. So as you could see, add cast to double cannot convert from double to float. So if you have to tell compiler that you are storing the float value, you have to say F. Now the error goes away. Right? Double. Okay. So we just say double num6 is equal to whatever. Right? Like so. And it's always a good idea to add d at the end, because then you'll say, okay, hey, this is of double type. It increases the readability. All right, guys, then we have got boolean. So we say boolean name of the variable is male, and we have to set it to either true or false, like so. Okay, please remember that you don't have to use single or double quotes, because single quote represents the character data type and the double quotes represent the string data type, but we are working with boolean. Okay, so please make sure that you do not make this mistake. Now last data type is your character, so we say char, and then I can say char a is equal to, and I can store a into this. Okay, like so. I can also store the numbers into it, so I can say char 20 is equal to, I can, let's say, store 70 in. So this is just like byte, but there is a major difference, guys. Char uses 2 bytes, okay, because char data type is a single 16-bit Unicode character. Now why char uses 2 byte in Java? Okay, it is because Java uses Unicode system, not ASCII code system. So Unicode is a universal international standard character encoding that is capable of representing most of the world's written languages. So before Unicode, there were many language standards like ASCII, COI8, Big5, etc. And that caused the problem like, number one, a particular code value correspond to different letter in the various language standards. Number two, the encodings for languages with larger character sets have variable length. Some common characters are encoded as single bytes, other require 2 or more bytes. You can find the list in here, and guys, you see it's a big list. Okay, it supports all these different characters, not just English. All right, so next is, guys, we have created this variable num3. So if I say num3 dot and I control space, there are no methods available. So primitive data type specifies the size and the type of the variable, but they do not have any additional method. Okay, now there's a concept called as wrapper classes in Java, okay, which we are going to cover into detail in an upcoming video. But you can also use wrapper classes to create these data types. For each of these 8 primitive data type, there is a respective wrapper class. So in this video, I'm just going to use the integer wrapper class to show you that when you create a variable using a class, you have access to certain methods which are not available in case of primitive data types. Okay, so you say integer num7 is equal to, you set it to 100. Now guys, when you say num7 dot, you see the list of methods available, right? Like so. So guys, most of the times you would work with these primitive data types only, but at times you require to pass in the object, and in those cases we are going to use the wrapper classes, and I'm going to create a video on wrapper class in future. Alright, so the last thing is, guys, constant. Now guys, variable is something which can be changed, and a constant is which stays fixed. Okay, the value once assigned cannot be changed. Alright, so how do we define that? So we say final keyword. All right, this is a non-access modifier. Then you provide the data type, so we say int, and then we say num9 is equal to 70. All right, and you can't change it at later point of time. So if you say num9 is equal to 100, that's not allowed. Okay, you get the error which states that the final local variable num9 cannot be assigned. All right, now there is a naming convention that you have to use, and that is whenever you work with the constants, You just use all uppercases. Okay, so for example, if you have to say num9, so you say it like so. Okay, one example would be you say final float pi. Okay, the value is fixed, so 3.14. You say f and like so. Now this is a constant and nobody can change this. Alright guys, that's for this video. I'll see you in the next video.